All right, in this video, I'm going to talk us through rational exponents, which is another word meaning fractional exponents. So when you see fractions as exponents like we do here, this is going to be how we're going to interpret those. The key thing to remember with fractional exponents or rational exponents is the importance of the numerator versus the denominator. When we rewrite these in radical form, which is what we see here, we're going to use the numerator, that's going to be the power or the exponent here, versus the denominator is going to represent what type of root we are taking. So we should really be thinking power over root. And some teachers will use kind of the idea of thinking about power lines being up in the sky, roots of a tree being down on the ground, to kind of remind you of this power versus root idea. So in this example, our root was 5, our power or our exponent is 3. This gets rewritten as x to the 3/5. I can also think of that similarly if I start with something like this, 5 to the 2/7 power, this would turn into a radical. 5 would be the radicand, the number under the radical. That was my base here. This is my denominator, so it's going to become the 7th root, and the power is the numerator, so that'd be 5 to the 2nd power, and then 7th rooted. Now this statement means that I can do the power versus the root in either order. So here I'm kind of thinking of this as doing the exponent first and then the root, whereas here I'm thinking of doing the root and then the exponent. And we'll see in an example in just a moment that that order is interchangeable. Okay, so this first example says we're supposed to rewrite it in radical form. So my answer should have a radical, then evaluate, and then my answer will just be a number. So if I rewrite this 9 to the 1/2, this would turn into the square root of 9 to the 1st. This is my power, this is my root. Well, when we write a square root, we don't write the 2, we just leave that off. It's just understood to be a square root. And similarly, 9 to the 1st is just 9. We can evaluate this down and just get the integer 3. On this one, I can rewrite it as the cube root of 27 to the 2nd power. This could be evaluated by doing 27 squared, which I do not know off the top of my head. So I'll do 27 to the 2nd power is 729. Then I'll cube root that. You actually have a cube root button if you go to math and then to option 4. You can do cube root of 729, which apparently equals 9. So that's one option or one route that I could do with this problem. The other option, based on our statement up here, is that I could go in the opposing order. I could do the cube root of 27 first, which I know that 3, since 3 cubed gets me back to 27, and then square that. And again, I get to 9. So either order gets us to that same answer. All right, in the second example, we're supposed to rewrite these using rational exponents, meaning our answers should end up with fractions as their exponents, and simplify those fractional exponents if possible. So this first example, 5 is going to become the base of my exponent. This is my power. This is my root. So I'm going to do power over root, 5 to the 6/7. Can't simplify that. I'm good. Over here, I'm going to do x. This is my power. This is my root. And x to the 4/4, that would just reduce to x to the 1st, which simplifies all the way down to just x. On example C, I'm going to have a to the 3/4, b to the 2/4, and c to the 1/4. All of these share the same root. The powers become all the numerators. And since there was no number on c, it's understood to be just a 1. Now I'm going to check to see if there's any simplifying I can do. This fraction here can be simplified, so I'm going to turn that into b to the 1/2. Neither of the other two can be simplified, so I'll just bring those on down. For letter D, Let's see, I don't see a root, I don't see an index to my radical, which means it's understood to be a square root. And 144, I'm just taking the square root of that. So one way to write that is 144 to the 1/2. Or I can think, what's the square root of 144? That goes down to 12. X to the 6th, and then square rooted becomes x to the 6 over 2, which would just be x cubed. Last but not least here, I'm doing the cube root of 8, which I could write as 8 to the 1/3. Let's see, the cube root of 8, 2 times 2 times 2 gets me 8, which means 2 cubed is 8. So the cube root of 8 is just 2. Then I'd have x to the 2/3, y to the 12/3. This can't be simplified, but this can. So I could write that as y to the 4th. Bring those all three down. All right, I'm going to pause here for this video, and then in the next video I will finish up these notes with example 3.